Hello everyone, welcome back to my YouTube channel. So today I'm going to solve problem number 3027. Find the number of ways to place people to. So let's read the problem statement. You are given a 2D array points of size n into 2 representing integer coordinates of some points on a 2D plane where points of I is equal to x and y, right? And we define the right direction as positive x-axis, increasing x coordinate, and the left direction as negative x-axis, right? So here this is nothing but positive x-axis, this is nothing but your negative x-axis. Similarly, we define the up direction as positive y-axis, so this is nothing but positive y-axis, and the down direction as negative y-axis, decreasing y coordinate, right? So here this is nothing but your negative y-axis, negative y here, positive y, positive x, and negative x. That's it, very simple, right? Now after that, you have to place n people including Alice and Bob at these points such that there is exactly one person at every point, right? Alice wants to be alone with Bob, so Alice will build a rectangular fence with Alice's position as the upper left corner and the Bob's position as the lower right corner of the fence. Note that the fence might not enclose any area, it can be a line, right? If any person other than Alice and Bob is either inside the fence or on the fence, Alice will be sad. All right, so Alice wants some alone time with Bob, right? So if Alice is going to place at the top corner, right? Here if you read this line, Alice will build a rectangular fence with Alice position as the upper left corner. So Alice, let's say here, upper left corner, and Bob here, and this can be like this also. Alice here and Bob here, right? This is also valid, and this can also be like this: Alice here and Bob here, right? All right. So Alice will be happy if only both are spending the time together. There is no one else, right? But if there is any third person, let's say here or here or here or in between or here, anywhere, right? Any other person, then Alice will be sad, right? So this is a little bit similar to yesterday's problem, right? Problem number 3025 that I have solved here, similar to yesterday's problem, right? Let's finish the problem statement first here. So what we need to do here, we need to return the number of pairs of points where you can place Alice and Bob such that Alice doesn't become sad on building the fence. Now if you see the examples here, see example number 1, right? So these are the points 1,1, 2,2, and 3,3, right? So these are the points. So there is no way to place Alice and Bob such that Alice can build a fence with Alice position as the upper left corner and Bob's position as the lower right corner, hence we return 0, right? So if you place Alice here, there is no place for Bob, right? Bob should be here or here, right? Like this, there's no place for Bob, right? Same way, if you start Alice here, then Bob should be here somewhere, right? In this position, right? Lower or in the right, right? Bob's position as the lower right corner, right? Here also, if Alice is here, then Bob should be here, okay, or here in between here, right? But Bob is not there, there's no point, so we are returning 0. Same like this example, right, of from problem number 3025, medium level, right? Part 1 of this problem, same example, right? Now see example number 2, 6244 and 26. This is also same, right? 624426, right? Same, right? So here also, if you see, Alice at 4,4 and Bob at 6,2, this is valid. Alice at 2,6 and Bob at 4,4, this is also valid. Alice at 2,6, Bob at 6,2, right? This is invalid because there is one more point in between, right? So place Alice at 4,4 and Bob at 6,2, place Alice at 2,6 and Bob at 4,4. You cannot place Alice at 2,6 and Bob at 6,2 because the person at 4,4 will be inside the fence and Alice is sad now, right? So total 2, right? So that's what we have to return here. Same here also, output was 2, right? Okay, now see example number 3. Example number 3, here see, Alice at 1,1 here and Bob at 3,1. So this is valid, right? This is valid, I have told you, right? We can take the line, right? Here Alice at 1,3 and Bob at 1,3. This is also valid. Alice here and Bob here, right? This Alice at 1,3 and Bob at 3,1, this is not valid. Reason is there is one more point here, right? So place Alice at 1,1 and Bob at 3,1, right? Place Alice at 1,3 and Bob at 1,1. You can place Alice at 1,3 and Bob at 3,1 because the person at 1,1 will be on the fence. Note that it doesn't matter if the fence encloses any area. The first and second fences in the image are valid. So valid, valid, right? Same thing here in this also, right? If you see example number 3, okay. And these are the constants, and until 50, and points I dot length is equal to 2 and 50, and all points I are distinct, right? For this 3025. For this one also a little bit difference, right? And it's until 1000, this is same, points is a little bit different, and here all points I are distinct. Means this line means that if 2 points are there, like x1 comma y1 and x2 comma y2, then it should not be like this, x1 is equal to x2 and y1 is equal to y2. So if the 2 points are like this, it is not possible. It's saying all points are distinct, so this should not be there, right? Always. So we don't need to check this condition if both the points are same, right? Okay. So I have already explained this problem 3025, right, yesterday in detail, right? What we are doing, why we are writing these conditions, all that stuff. So if I just copy this code of 3025 and I just paste it here in 3027, let's see if I'm able to pass all the test cases or not. I'm able to pass all the test cases. Let's see if I can submit the same solution for 3027. Let's see. Yes, I'm able to submit, right? For this one, time complexity is of n cube, because here I'm running I loop, here I'm running j loop, right? And here I'm running k loop. Okay, so I will add the link of this video in the description of this current video, right? Part 1, so you can also watch this, right? For this one, time complexity is of n cube, but can we optimize this solution? Can we optimize this solution for this 3027? Because here if I submit this problem in 3025, right? So I'm here, but if same code I'm submitting here, right? If you see same code I'm submitting for 3027, so I am here, right? So let's optimize a little bit, right? But we are able to submit. Okay, why we are able to submit of n cube? Because here of n cube, if I'm saying so, n is also very small here, right? In this problem also, right? So that is why I'm able to submit. But let's see the optimization of this one. All right. Okay, so here I'm just going to reset the code for 3027. Done. Okay, so now how I'm going to optimize it, let's see. So let's understand this with this example only, example number 2, right? So these are the points given to me, right? 6 comma 2, 4 comma 4, right? So here, okay, these are the points 6 2, right? So here let's say if my eye is at this position, right? Let's say if my eye is at this position, let's say Alice, right? If for Alice this is the position, right? So I can say that 2 comma 6 I'm saying for Alice, right? For Alice, and I'm saying this is my eye, let's say, and let's say the coordinates are x1 comma y1 for this one, right? So for Bob, what I need to search, I need to search a coordinate. Let's say for Bob, my coordinates are x2 comma y2, right? X2 comma y2. So for Bob, I want to make sure, right, my x2 value, right, my x2 value, it should be greater than equal to x1, right? This will be the very first condition, right? My x2 value, it should be greater than equal to x1, right? So if let's say this is the graph that I have, and my Alice is here, right? X1 comma y1. So now for Bob, right, I want my x2 such that it should be greater than equal to x1, right? Always like in this range, right? In this range it should be there. It should not be before this, right? If it is before, then definitely I can't place Bob in the lower right corner, right? Then I can't place, right? So what I'm saying here, that my x2 value, it should be greater than equal to x1, right? Because I need my Bob to be at lower right corner, right? So I can do one thing here. If I am here, then again I'm searching from this position again and again, right? I can sort my points array in such a way that the smaller value of x, it should come first, right? I can sort my array like this, because if I sort my array like this, so then it is going to become like this: 2 comma 6, right? And then 4 comma 4, then 4 comma 4, and then after that 6 comma 2, right? 6 comma 2. right? So now here if you see this, if my Alice is here, then I need to check these points for Bob only, right? Because in these points only my X value is greater than this X, right? Same way, if my Alice is here, then I have to just check these points only for Bob, right? I don't need to check this because in this X value is smaller than this X, right? So this is one optimization I did here right now. Clear with this? Okay, so first point, sort the array based on the x-axis, right? So sort by x in increasing order. Sort by x in increasing order. Increasing order, right? Okay, this is done. Now here second thing, if Alice is here, right, then I need Bob to be in the lower right corner, right? So Bob can be here and Bob can be until here, right? So Bob can be here in this range, right? Bob can be here in this range and here also, right? Because if y is same in the same line, right, that is also possible. Here if you see this example, right, y is same, so this can be the condition, right? But Bob should not be here, right? Bob should not be here, okay? Because here in this case, if Bob is here, then for Bob, let's say x2 comma y2, right? X2 comma y2. So here in this case, if you see y2 is greater than the y1, right? So Bob is not in the lower right corner, but he is in the upper right corner, that we don't want, right? So Bob, that is nothing but y2, okay? This y2 value, it should always be less than equal to y1 value, right? So this is one thing I have explained here, and this x2 should be greater than equal to x1, right? Clear with these 2 points, right? Okay, this is done, right? This is what we need to make sure first. Okay, so now here, all right, so these are two things, right? And here if you notice one more thing here, if you see this example, right, if you sort your array like this, the way I'm saying, let's suppose I have these points, right? So you are going to sort it like this, let's say 1 comma 1, then 1 comma 3, then 3 comma 1, right? This is a valid, right? Based on x-axis if you sort like this, okay, this is valid. Now here if you place your Alice here at 1 comma 1, and then for Bob you need to check all these points, right? Okay, so Alice at 1 comma 1 now sitting here 1 comma 1, let's say, and Bob is at 1 comma 3. So these 2 points are giving invalid result right now. You are placing Alice here and you are placing Bob here, right? 1 comma 3, right? Let's say this is the graph. So you are placing Alice here and then Bob here, then this is invalid. But if you sort the array like this, first 1 comma 3 and then you write 1 comma 1 and then you write 3 comma 1, right? Here also I'm sorting based on x-axis also only, right? But here for Alice and then for Bob, these are the points. So Alice is 1 comma 3, let's say here 1 comma 3 and then Bob here, right? 1 comma 1. So that simply means this case Alice here, Bob here, so then it is valid. So one more thing that you need to take care here, that first you have to sort the array based on x-axis in increasing order. Then after that, here just make sure that if the x is same, if x is same, right, for both Bob and Alice, then you have to sort the array with consideration of y in decreasing order, with y in decreasing order, right? So this is the observation, right? Here I did, okay, right? So here if you see 1 and 1 both are same, then after that I sorted based on y in decreasing order, right? Because now this is giving me, these 2 points are giving me valid result, right? But here these 2 points are not giving me valid result. Okay, this is done. All right, okay, this is done. Now here if you see this graph now, 2 6, first let's say, let me just remove it, let me just remove this. So let's say this is your I, and now for j you have to check these points, right? All these points. So I is 2 comma 6 and the j point is 4 comma 4. So 4 comma 4, let's say here somewhere here 4 comma 4. So now this is valid, right? This is valid. Why this is valid? Because here this is nothing but x1 comma y1 and this is nothing but your x2 comma y2. So this is valid because your x1 is less than equal to x2, and your y1, this y1 is greater than equal to your y2, right? This is valid. Okay, this is valid, right? Now this is valid. Okay, this point is valid. Now after that, this is the first j you checked, right? Now your j is going to move here, right? J is moving here. So now here, if I just slide this space somewhere here, right? This is nothing but 6 comma 2. Okay, 6 comma 2. So let's say here somewhere 6 comma 2, 6 comma 2, right? Now let me do one thing here. Let me just remove this, right? Let me just remove this. Okay, so now here 6 comma 2, and these are your new x2 comma y2. So here if you see this, now you are going to say that this is also valid, right? Because my x1 is less than equal to x2. Good. Y1 is also greater than equal to y2, right? Y1 is also greater than equal to y2. This is, you are going to say this is also valid, and Alice is happy, but no, she's not happy because of this point. So there can be any number of points in between these two, right? This is I and this is j. There can be any number of points, right? Okay, so now how I'm going to solve it again? If I run from start, take this as k, take this as k, take this as k, all the points. So that simply means that I'm trying to solve this problem like this, like this. Okay, so then it will be O of n cube, right? So now let's utilize the sorting that we did, right? So what I'm going to do here, from here I'm starting, right? This is Alice. So for Alice, if you see, what is the here for Alice, this is the x coordinate and this is the y coordinate for Alice, right? Okay, done. And now after that you are running this j loop, right? J loop, right? So inside this j, just keep track of the maximum y value, maximum y value in this one. So here, from here you start, and then from here you keep start the tracking of the max y value. So I will create one variable, best bob by. Let's say best bob by means the best value of y, right? So here best value is 4 right now, and for this one the best value is 4 only, but this value is 2. So this value is 2, and we are starting from here, right? And best value is 4, which is greater than this one, right? Which is greater than this one. So in that case I am going to simply return false. I will say that this is not valid, right? Bob, this is not valid, right? So here I can say bob by. Okay, if okay, this is not valid, but let's say if my point instead of 6 2, here we have 6 5. Instead of 6 2, if I have 6 5, if I have 6 5, 6 5 will be here somewhere, 6,5. Then this is valid, right? This is valid because in this rectangle, this value, okay, this bob current y, okay, this is greater than the best bob y, previous best bob y, right? So this is valid because now this point comes here a little bit down, right? Then it is valid. So for bob, I'm always going to keep track of the y value, right? It should be the new value, okay, whatever the new value, it should be better than the best of y, right? If it is not, then not add it. Okay, if it is better than that, then update the result by 1, and then take this as the best value of y yet, right? So I, and here you are just running j. The next time your I start from here, then next you have to check j's like this. That's it. Okay, and these are already sorted in the x, right? So we have already taken care of in between the points, and but we just need to make sure that even if there is one point, there is one point, let's say they both are forming one rectangle, right? We are just moving like this, right? So here for this and this to make one valid scenario, I just want to make sure that the previous best y value, it should be below this, it should not be in between. Okay, so if my b comes here next time, so then it is going to cover these 2 points, right? It should be above these 2 points. That's it. That's what we need to make sure, right? That's it. Very simple, very simple, nothing complex, only very few lines of code. Okay, so now let's write the code. Okay, whatever I explained, I'm just going to write the same thing. Very simple. Okay, so here let's write the optimal solution, right? So we are just doing the sorting one time. So for that, a time compressor is going to be O of n log n, and then after that we are just running 2 loops, right? I and j. So for that, n square. So total you can say O of n log n plus O of n square. So overall you can say O of n square only, right? That's it. So here what you need to do, int n is equal to points dot length, and then here you have to sort by x ascending, and here if x is same then by descending. All right, and now here you write arrays dot sort points a comma b, right? And here I will just write there are two. Okay, I am sorting this points array. Let's suppose there are two parameters a and b. So first, if here I'm just going to write if the a of 0, right, if a of 0 is equal to b of 0, right, in that case what we need to do, we have to sort them with the higher y first, right? So here I'm just going to return b of 1 minus a comma 1, right? So here you can say higher y first, right? And in the else part you have to simply return a of 0 minus b comma 0. That's it. Okay, this is nothing but smaller x first. That's it. Okay, this is done. Now after that, here you have to just create one variable result is equal to 0, and then you have to just run one loop int I is equal to 0, I is less than n, I plus plus, and here inside this int alice x, let's use these variables, okay, for simplicity. Points, you can say points, and here you can say I comma 0. All right, and here alice y is equal to points, and here you can say I comma 1, right? So this is alice upper left, alice is upper left, right, upper left. Okay, this is done. And then best bob by, right? So int best, let's say bob and by, right? I have to keep track of this, so I will say initially it is nothing but integer dot min underscore value, right? Okay, and then here I have to just run one j loop int j is equal to I plus 1. That's what I explained, right? And here j is less than n, j plus plus, and here just like for alice we need to take for bob also, right here. So I will just say int bob x is equal to points j comma 0, and here int bob y is equal to points j comma 1, and this is nothing but bob is lower right, you can say, right? So here let me just write it like this, bob is lower right, lower, and here right. Okay, that's it, done. Here I have created these two variables, right, for bob also. And then here first thing, bob must not be above alice, right? Bob must not be above alice, right? So here if bob y is greater than alice y, then in that case simply continue. All right, and here we have to ensure no intermediate point invalidates, no intermediate point invalidates, let's say invalidates the pair, right? So in that case you have to just write if bob y value, if it is greater than the best bob y. All right, if this is the case, then simply do result plus plus, result plus plus, and here best bob y, just update it with bob y. That's it. Okay, bob y, that's it. All right, and here you have to simply return result, return result. That's it. Okay, so now let's run the code and see if there any code issue. We'll try to fix that. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And we are here. So now time compressor is of n square, right? Of n log n plus of n square, or you can say overall of n square, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. We'll see you in the next video. Thank you. Bye bye.